Hello, you. Welcome back to class. Today we are going to spend our time in the fascinating world of blood vessels. Yep, arteries, veins, and capillaries. Oh my. We will start with a look at the general structure and function of blood vessels. The blood vessels, or vasculature, exist to circulate blood throughout the body in a closed vascular loop. Important general concept forthcoming. Arteries carry blood away from the heart, while veins carry blood toward the heart. In systemic circulation, oxygenated blood flows from the left ventricle of the heart into progressively smaller vessels known as the arteries, arterioles, and capillary beds, where exchange between the blood and tissues occurs. The now deoxygenated blood flows back to the heart through progressively larger vessels from the capillary beds to the venules to the veins before draining back into the right atrium. Generally speaking, the anatomy of the vasculature is similar. With the exception of the capillaries, which only have one layer of tunica intima, the other vessels have 3 layers, just like we sometimes like to wear 3 layers of clothing, but not that often here in hot, humid Houston. The innermost layer is known as the tunica intima. This is a very thin layer of slick squamous epithelial cells that faces the lumen or inside of the blood vessels. It is slick to help reduce friction as blood moves through, like a slide. Whee! The middle layer is known as the tunica media. This layer contains the smooth muscles and elastic fibers necessary for vasoconstriction and dilation. This layer is under the control of the sympathetic nervous system. The outermost layer is the tunica externa. This layer contains a lot of fibrous tissue to support and protect the vessels. From general vessel anatomy, let's move into more specific anatomy by vessel type. Recall that arteries carry blood away from the heart. They are what is known as the blood pressure reservoir. A reservoir is a supply or source of something. In this case, arteries are a supply or source of pressure to keep the blood flowing from the heart to the veins or from the areas of highest to lowest pressure. Because they have to handle all this pressure, they have anatomical adaptations to keep them from exploding. Hooray! Specifically, arteries tend to have thick walls with a heavy tunica media. This middle layer has lots of smooth muscle and elastic fibers to allow the arteries to expand and recoil without permanent stretching. Neat. While arteries are a pressure reservoir, veins are the blood volume reservoir. Rather than storing pressure to drive blood flow, veins store the blood itself. Their walls are relatively thin compared to arteries, as they don't have to combat the high pressure seen in the latter vessels. Also, they have a heavier tunica externa with its fibrous tissue to support and protect its precious contents. Veins also have a unique one-way valve system that keeps blood moving toward the heart, even against gravity. Cool. While arteries are designed to handle high pressures and carry blood away from the heart, and veins are designed to handle high volumes and carry blood toward the heart, capillaries are the vessels of exchange. Here, flow is minimal, and blood and tissues have the opportunity to exchange oxygen, nutrients, carbon dioxide, and waste. Because of this, they also have anatomical adaptations to facilitate their function. Primarily, capillary walls are really thin and consist of only a single layer of tunica interna. This makes it super easy for stuff to move in and out of them. Capillaries also have vascular shunts, which provide the option to bypass that particular area and forego exchange. In fact, you can have anywhere from 10 to 100 capillaries attached to each vascular shunt. The precapillary sphincters are circles of vascular smooth muscle that open or close to allow or bypass exchange respectively. Wait a minute. Why would you want to bypass tissue exchange? Well, say you're in that fight or flight mode and need more skeletal muscle circulation to escape and less digestive circulation. Use a shunt to bypass the intestines. Or say you're in danger of hypothermia. Use a shunt to bypass cutaneous blood vessels and keep the blood warm in your core. Brilliant! Now that we have a basic understanding of the anatomy of the capillaries, let's switch and take a closer look at their physiology. Concentration gradients, or differences in concentration between the blood and tissues, drive gas and nutrient exchange. Some molecules like oxygen and carbon dioxide can move through using direct diffusion. Other things like fluids and small solutes can move using diffusion through intercellular clefts or gaps between the cells in the capillary wall. Some capillaries, known as fenestrated capillaries, have pores or fenestra, which are more permeable and allow for easier diffusion of liquids and solutes. Fenestrated capillaries are usually found in tissues with a high absorption priority, like the intestines. Finally, larger molecules and those that are lipid insoluble can be moved using vesicles via endo or exocytosis. The key players in driving exchange are capillary blood or hydrostatic and osmotic pressures. At the arterial end of the capillary bed, hydrostatic pressure exceeds osmotic pressure, driving fluid out into the interstitial fluid in a process known as filtration. At the venous end of the capillary bed, osmotic pressure exceeds blood pressure and causes fluid to enter the capillaries in a process known as reabsorption. Fascinating. While there are many blood vessels in the body, we will now attempt to label some of the major arteries and veins in the human body. To make it simpler, we will explore them by body region. And I drew them, so don't laugh. I was a music major, remember, not an art major. Major arteries of the head and neck include the right and left common carotid arteries, which then branch into the right and left internal and external carotid arteries, and the right and left vertebral arteries, which run in the transverse foramen of the cervical vertebrae. Major arteries of the trunk include the aortic arch coming directly off the left ventricle, which becomes the descending aorta, which continues as the abdominal aorta, which supplies blood to the major abdominal organs and the entire lower half of the body. Major arteries of the upper extremity include the subclavian artery, which continues as the axillary artery, which becomes the brachial artery, which is often used to assess blood pressure. The brachial artery splits to become the radial and ulnar arteries, which end in the palmar arches of the hand. Major arteries of the lower extremity include the common iliac artery, which supplies blood to the entire lower leg and continues as the femoral artery at the thigh, which continues as the popliteal artery at the knee, and then splits into the left posterior tibial artery and the left anterior tibial artery at the lower leg, which continues as the left dorsalis pedis artery on the top of the foot. Of note, the dorsalis pedis artery is very important in monitoring blood flow to the feet, particularly in people with diabetes. From major arteries, we now switch to major veins. Major veins of the head and neck include the right and left external and internal jugular veins. Major veins of the trunk include the superior vena cava, draining blood from the upper half of the body, and the inferior vena cava, draining blood from the lower half of the body. Both vena cavae are the ultimate venous destination and drain directly into the right atrium of the heart. Major veins of the upper extremity include the cephalic vein and the radial and ulnar veins, which merge to form the brachial vein, which combines with the basilic vein to make the axillary vein. All veins from the upper extremity lead to the superior vena cava. Major veins of the lower extremity include the dorsal venous arch. You also have a plantar venous arch, which drains into the anterior tibial vein, which joins the posterior tibial vein to form the popliteal vein, which continues as the femoral vein, which also receives blood from the great saphenous vein and continues as the external iliac vein. Phew! All lower extremity veins ultimately lead to the inferior vena cava. That was a lot of vessels. Well, that does it for blood vessels. See you next time.